Okay, if an object is dropped from a height of 144 feet, the function height after t time equals negative 16t squared plus 144. You see the number there saying it's dropped from that height, so we need to shift the thing up to that height. And we know that that number at the end shifts everything up. Okay, gives the height of the object after t seconds. When will the object hit the ground? Well, the question really is, okay, um, it will hit the ground when the h value, the height, is 0. So instead of like we can have this function, we can say h of t equals negative 16t squared plus 144. But then what we're saying is, okay, what if then the height, which is everything that's on the left of the equal sign, all of this, right? Height, the height after a certain number of seconds. When does it hit the ground? Well, it hits the ground when that height is 0. Okay, so we put a 0 in there. And we say, okay, now we don't have two variables anymore. Now we've just got the one variable of t, and we can solve this. How do we solve it? Well, there's multiple ways that we can solve it, but I think that the best way to do it is using square roots. So watch what we'll do. We'll say plus 16t squared to both sides. And we get 16t squared is equal to 144. We don't want to know what 16t squareds are. We want to know what just t squared is. That's when we can square root it. So let's divide both sides by 16. We can say 16t squared divided by 16 equals 144 divided by 16. That will result in t squared here, and this will result in, let me think about it, it's going to be 9. That's going to be 9, okay? So if we then square rooted both sides, if we said, what is the square root of t squared? That'll be equal to the square root of 9. And then t is equal to. Now, when you square root 9, you get 3 or positive 3. I'm sorry, positive 3 or negative 3. I misspoke there. And that's saying that it's either, we can write it down as positive or negative, just for a second to think about it. After 3 seconds, it would hit the ground, but also 3 seconds before it's dropped, it was on the ground, okay? Nope. If you traced the entire parabola through the sky without regard to the fact that the ball was dropped, the parabola being formed would, if it was somehow a coordinate grid, you'd see it on the ground at 3 seconds after and, in the same place 3 seconds before, but 3 seconds before it was dropped, it wasn't moving. The parabola doesn't go backwards in time to before the event started. So you can't have negative 3 seconds. You can't say 3 seconds before we dropped it, it was on the ground. Nope. Nope. 3 seconds after you dropped it, it was on the ground, not before. So this is one of those situations where even though the square root of 9 is both positive and negative 3, the answer of negative 3 doesn't make sense in this context, and we're going to get rid of it. We can't have that as an answer. Okay, it doesn't make sense. It's an extraneous solution, an extra solution that doesn't make sense in our problem. Okay, t seconds, after 3 seconds, that's when the object will hit the ground. That's the only one that makes sense, and that is D. Okay? Okay, a ball is thrown into the air with an upward velocity of 48 feet per second. When you see that, how does that look in your equation? That's right here. Okay? You don't have to know all this, you just need to know that this equation represents it. Okay? So if the ball is thrown up with an upward velocity of 48 feet per second, meaning it's not just let go, but it's actually thrown up. And that's what velocity means, is you're actually putting some force into it to propel it. Okay? Then its height in feet, the height is h, after t seconds is given by this function. If we knew the number of seconds that it was thrown, well, how long ago it's since it's thrown. I said that incorrectly, sorry, but how long since it has been thrown, then you can plug that number in and find out where is it. Okay, well, they're not asking quite for its position in some random amount of time. They're asking for very specifically, how long does it take the ball to reach its maximum height? Okay, so let's see. We need the vertex point, yes? Okay, so if we need the vertex point, then what we're going to do is we're going to say, okay, I need to identify the axis of symmetry, and that's x equals negative b over 2a. And what is b? Well, b here is 48. Okay, so I can plug in 48 over 2 times what is a? And a is negative 16. Okay, and so when I calculate that out, I say x equals negative 48 over negative 32. And negative divided by negative is positive, so we're going to get a positive number. And I can divide these both by 16, and what I get is 3 over 2. So that's the x-coordinate. That's equivalent to 1.5, and so you see 3 of the answers have 1.5 as the x-coordinate, right? The number of seconds. And so we can eliminate the one that doesn't because we know that it has to have that. So we can cross that out. Okay. And then how do you find out what is its maximum height? So what you need to do then is take the original equation of, and I'll write it here, h equals negative 16 t squared plus 48t plus 6, and we're going to plug that in. We're going to say negative 16 parentheses 3/2 squared plus 48 parentheses 3/2 plus 6. Okay, and then you'll just need to know a little bit of how to calculate. You'll need to, this is where it's just kind of, we just can't get away anymore with not knowing fractions. 9/4 plus 48 times 3/2. Let's see, 48 divided by 2 is 24, and then 24 divided by, or multiplied by 3 is 72 plus 6. Okay, how do we resolve this? Well, the negative 16, what I did up here, I canceled this and this out. Just in my mind, I said 48 and 2. They cancel out, giving us 24 here. Okay, and then I multiplied by the numerator 3 to get that 72. So I'm going to do the same thing here. I'm going to say, crossing these out, this 4 and this negative 16, we get negative 4 there, and then negative 4 times the 9 is negative 36 plus 72 plus 6. Negative 36 plus 72 is 36 plus 6 is 42. Yeah? And that gives us, for the point that we're looking for, we have an x-coordinate of 3/2 and a y-coordinate of 42. And that is, after 1.5 seconds, it is 42 feet in the air, and that is choice B. Yeah? So this might be a little mind-boggling to you. It's an application of what we learned. Okay, but if you want to know how long does it take to reach its maximum height, and you know that essentially t represents just like the x-coordinate, right? That's the input, the independent variable. Then you can treat t like it is x, and you can say, okay, well then it's just like y equals negative 16 x squared plus 48x plus 6, and then say I want to find the maximum height, so that's the vertex point, so I can first find the x-coordinate of that with x equals negative b over 2a, And when we calculate that down to 3/2, we plug that in to find out what comes out. Okay? This is useful. It actually is useful. Well, one more. Okay. A catapult launches a boulder with an upward velocity of 112 feet per second. Because it's being forced upward, it's being thrown upward with this particular velocity, then this is where you see that velocity. It's pretty neat. Okay, this is the standard, just for fun, just to tell you, this is the standard speed at which something falls, -16 t squared. That's how things fall in the world. Okay, so that you're always going to see that when you see something either being thrown or being dropped, where you have the force of gravity working on it. Okay, and then this bit of it, the t value and the coefficient of that is the velocity that it's thrown with. Okay, and the last bit of this is this plus 30 right here. And what's being represented by this plus 30? That's the whole thing started when it was thrown from 30 feet above the ground. Okay, so you can take all these factors that you know, the fact that things fall on Earth at a certain rate, that's the box in green. Okay, you can take the height that it was initially thrown from, 30 feet up, that's circled in blue, and then the force with which it was thrown, or catapulted in this case, 112 feet per second, that is underlined in pink. Okay, all of those particular real life things come together to make the values of an equation that you can then use to calculate stuff. So, how long does it take the boulder to reach its maximum height? Well, remember, what we're trying to do here then is say, we're looking for the x-coordinate of the vertex. And how do we do that? We do that with x is equal to -b over 2a. And then if that's the case, we then say, okay, then x is equal to the negative of whatever the b value is, divided by 2 parentheses, whatever the a value is. So, in this particular problem, let's look up top. The b value is positive 112, and the a value is -16, just like it's going to be for all of these types of problems where your gravity is working on these things. So we've got -112 over -32. The negatives cancel out, and we've got 112 divided by 32, and let's see, if we did 32, well, 112 divided by 32, okay, I can say, I know 96 is 32 times 3, okay, and if we did 96, we couldn't get another 32 in there before going over, so I know there's got to be 3. So I say that's 32, I'm sorry, that's 96. Subtract that away. So what I have to do, I have to borrow from here. That becomes 0, that's 12. We get a 6 there. And this whole thing, 10 minus 9 is 1. And I'm going to annex a 0 and bring it down, because I know that since 16 is half of 32, then 160 is 5 times 32. Happy to talk about that idea with you sometime if you like. But anyway, 5 times 32 is 160. Exactly. And so that means that x equals 3.5. If we were graphing this, that would be the axis of symmetry. But we're not graphing it. All we're doing is using this number to say, it says how long does it take the boulder to reach its maximum height? It takes 3.5 seconds. And then what happens is gravity overwhelms the upward velocity as it slows, and then stops. That's how long it takes to get to that highest point, and then gravity and the upward velocity cancel each other out, and we hit that highest point, and just for that instant, it's at that highest peak and kind of stopped, and then it's changed direction and it's falling after that 3.5 seconds. But the question is, what is the maximum height that it reached? So that's the second question. So we're going to take the equation. We're going to say the height that it reached after 3.5 seconds, which we know to be the maximum, is negative 16t squared plus 112t plus 30, and then negative 16 parentheses 3.5 squared plus 112 parentheses 3.5 plus 30. Okay, and then we got to calculate it out. This will take me a minute to calculate. It'll probably take you a minute to calculate too. I appreciate that some of you are maybe a little out of practice with big numbers, and that's okay. We're going to do this however long it takes. This is how you do it. And we might not give you these hardest problems, but you certainly should, even if you're having trouble with the basic calculations, you should get yourself to the point of understanding, okay, well, I know what all to do, even if I don't have a calculator to do it, and so I have a hard time with, for example, squaring 3.5. I'm going to do that myself right here, over on the side. 3.5 times 3.5. 5 times 5 is 25. Carry the 2. 5 times 3 is 15. Plus 2 is 17. 0 placeholder. And we no longer need this 2. Okay? Now, 3 times 5, 15. Carry the 1. 3 times 3, 9. Plus 1, 10. Now I'm going to add them together. And in my problem, there was 2 digits that fell behind a decimal, that were behind the decimals in the numbers. So there's 2 total here for our answer. So 12.25. Now what do I need to do? Now I need to multiply that by 16, because once we do the squaring, we need to do the multiplying. Okay, so I'll write that over here. Rewrite my number, 12.25, and then we multiply that by 16. I know that the answer is going to be negative, so put a negative down at the bottom here. Why negative? Because it says negative 16 here, not 16, but that doesn't help us when we're calculating to put the 16 in for the moment. So let's multiply it. 6 times 5 is 30, carry the 3. 6 times 2 is 12, plus 3 is 15, carry the 1. 6 times 2 is 12, plus 1 is 13. Carry the 1, and 6 times 1 is 6, plus 1 is 7. Okay, we've already carried all those numbers and used those up, so I'm going to get rid of them. Just make it visually clean. And what we need to do is have a 0 placeholder. Now we multiply with a 1. 1 times 5 is 5. 1 times 2 is 2. 1 times 2 is 2. And 1 times 1 is 1. So when we add them up, we get 0, 0. Carry that 1. 6, 9, and 1. And the negative landed wrong, so I'm going to put the negative in by saying, just move that negative up there. But notice this, there were 2 digits total in the numbers we multiplied behind the decimal. So we're going to have 2 digits total behind the decimal in our answer. And we get negative 196 for all of those calculations. So that becomes negative 196. Great. I'm going to get rid of all these calculations because we're done with them. We just needed to find that number. If this seems hard and tedious, I would just say that, I would just say that, math requires you to be patient. And if you don't have patience, it's less about it taking a million years and being horrible and boring. It's more just like, be patient. Everything in life that's important is not necessarily quick and easy. And if you always have to go with quick and easy, then you're only going to do things that are only quick and easy, and you'll miss out on a lot of stuff. So be willing to spend some quality time working on a problem, and then be proud of yourself when you get to the end. So we're going to continue with this problem, and we're doing this part right here, which is the 112 times 3.5. And 5 times 2 is 10, carry the 1. 5 times 1 is 5, plus 1 is 6. 5 times 1 is 5. Okay, we've carried those numbers, so I'm going to erase that. And we need a 0 placeholder because we're moving under the tens place. Right, we're multiplying with the tens place, so the first digit needs to land right below it. That means this placeholder just keeps that from ending up there. It's got to go straight down. Yep. So 3 times 2, 6. 3 times 1, 3. 3 times 1, 3. Add them together. We get, okay, now here's the trick. That's not our answer yet because we have a single digit behind a decimal in the numbers that we multiplied. And so we're going to have a single digit behind the decimal there, and we get that number equaling positive 392. And then we have this plus 30 at the end. So now what we got to do, I'm going to get rid of the calculations now, over here. Now what we've got to do is add these all together, find out what that height is. So I know that 392 minus 196 is the same as, negative 196 plus 392 is the same as 392 minus 196. Okay, that's how it works. The negative is still with the 196 and the positive sign is still with the 392. So we can change their order. And now we can say, okay, I got to borrow from that. Make that an 8. That's 1. 12 minus 6, 6. Now 8 isn't enough to take away 9, so I got to borrow from 3 and make it 2. That makes that 18. 18 minus 9, 9. 2 minus 1, 1. Oh, look at that, same number. So I guess 392 is 196 doubled. So 196 plus 30, and then we get this calculations out of there. That is 196 plus 30 is 226, is the maximum height that it reaches after 3.5 seconds. Where do we see that answer? We see that answer in D. Okay. Yeah, that took a while. And again, you probably won't get, we won't give you a problem with quite the numbers like that. But beyond the difficult calculations of multiplying, squaring decimals and negative numbers and big numbers, hopefully what you're seeing is like, okay, yep, at least I get that. I know that you take the negative of the b value divided by twice the a value, and that gives me the x coordinate of the vertex. Then I plug that x coordinate, 3.5 in this case, into the original equation, and I can find out what the output is. And in this case, the output represents the height. The input is the number of seconds. And I'll box this so we'll be done.